Welcome to the Deep Dive. We're all about understanding how things work, and today we're going deep on something that powers a lot of our lives: batteries.
That's right. Batteries are pretty fundamental to our modern world, wouldn't you say?
Absolutely. And you, our listener, have brought us some fascinating sources that chart the history of battery technology. So we're taking a trip back in time, exploring the rise and, well, the partial fall of nickel-based batteries.
It's a story with some twists and turns. But before we jump into the lithium-ion era that we know so well today, we've got to understand the batteries that came before.
Exactly. We're talking nickel-cadmium and nickel-metal hydride batteries. You've probably heard of them, maybe even used them.
Oh, definitely. They were the workhorses of the rechargeable battery world for quite a while.
So our mission is to unravel their unique journeys, what made them so important, what led to their success, and ultimately what caused them to fade from the spotlight.
It's like understanding the roots of a tree. You've got to look at the foundation to really appreciate how it grew and branched out.
Perfect analogy. Okay, so let's rewind the clock. Our sources take us all the way back to 1899 to Sweden, where Waldemar Jungner invented the nickel-cadmium battery.
Wow, 1899. That's even before the first Model T rolled off the assembly line.
Right. We're talking seriously old school tech here. But what's really fascinating is that even back then, Jungner's invention was a huge leap forward.
It was a true game changer. Back then, rechargeable batteries weren't really a thing. You had single-use batteries and, of course, the bulky lead-acid batteries used in cars.
Yeah, not exactly portable. So the idea of a reusable power source, something you could recharge and use again and again, that was a radical concept.
It really was. Imagine the possibilities it opened up. But there was a catch, wasn't there?
There was. Our sources mentioned that the initial cost of these early Ni-Cd batteries was, well, pretty prohibitive.
Makes sense. New technology, especially something as complex as a battery, is going to come with a premium price tag.
Right. So even though the idea was revolutionary, it took a while for Ni-Cd batteries to become widely adopted.
It wasn't until the 1940s that things really started to change. That's when advancements in manufacturing and materials made them more affordable and practical for everyday use.
And once those barriers were broken down, Ni-Cd batteries really started to take off. One thing that really jumps out from our sources is their incredible durability.
Oh yeah, they were known for being tough. They could handle being completely drained, then charged back up quickly over and over again. Not all batteries could handle that kind of abuse.
That's so important, especially for portable devices. You don't want your battery dying after just a few uses.
Exactly. That robustness made them ideal for things like power tools. You could drain the battery running a drill, slap a fresh one in, and keep going.
And speaking of tough, they could also handle extreme temperatures, which is crucial for applications like emergency equipment.
You're right. Whether it's freezing cold or scorching hot, Ni-Cd batteries could be relied on to deliver the power when it was needed most.
Like those emergency lights that kick in when the power goes out, you want to know those batteries are going to work no matter what.
Absolutely. They were also used in aviation in aircraft emergency systems. Reliability was paramount in those situations.
And it wasn't just about toughness. They were also known for their high discharge rates. What does that mean exactly?
It means they could deliver a lot of power in a short burst, which is perfect for things like power tools that need a surge of energy to get going.
Ah, okay. So they could handle both high demand situations and long-term use.
Right. And they had a long cycle life, meaning they could be recharged many times before they started to lose their effectiveness.
Our sources give some great examples of how these batteries were used in the 1970s and 1980s. We're talking early portable radios, flashlights, cameras, even the first personal music players.
Yeah, those clunky cassette players that were all the rage. Remember those?
Vaguely, I'm more familiar with the MP3 era. But it's amazing to think that those early portable devices wouldn't have been possible without the Ni-Cd battery.
It's true. They were a key enabler for that first wave of truly portable consumer electronics. And it wasn't just about entertainment.
Right, they also powered things like cordless power tools.
Exactly. Drills, saws, screwdrivers. All of a sudden, you could use these tools without being tethered to an outlet.
That must have been a huge shift for a lot of tradespeople.
Absolutely. It freed them up to work more efficiently and in places they couldn't before.
And beyond power tools and consumer electronics, they were used in all sorts of applications.
Oh yeah. Telecommunications for backup power systems, medical devices like portable defibrillators and infusion pumps.
It's incredible how widespread their use became. It really highlights how essential this technology was for so many different
It
fields.
does. And they came in a range of sizes, too. You had the small sealed cells that we're familiar with from things like AA batteries, but also much larger ventilated cells used in industrial applications.
So versatility was another one of their strengths.
For sure. They were adaptable to a wide variety of needs.
Okay, so let's recap the Ni-Cd success story. They were reliable, could handle rapid charging, had low internal resistance for high power output, and could operate in a wide range of temperatures.
Sounds like the perfect battery, right?
Almost. There was one major drawback that our sources mention, the dreaded memory effect.
Ah, yes, the memory effect. It was a bit of a pain, especially for certain devices.
Can you explain what that actually means for the user?
Sure. Imagine you have a device that only uses a small portion of the battery's capacity before you recharge it. Over time, the battery sort of gets trained to only hold that much charge.
So it's like it forgets its full potential.
Exactly. It develops a kind of memory of that lower charge level, and its overall capacity decreases.
And this was a problem with Ni-Cd batteries.
It was, especially in things like watches and calculators that often only used a small portion of the battery's charge before being plugged back in.
So what could you do about it?
Well, you had to fully discharge the battery before recharging it to kind of reset its memory.
Sounds like a bit of a hassle.
It was not the most user-friendly aspect of Ni-Cd batteries.
Okay, so that's the story of the nickel-cadmium battery, the rechargeable pioneer with its own quirky personality. Now let's move on to its successor, the nickel metal hydride, or NiMH battery.
Ni-MH, the next generation. It picked up where Ni-Cd left off, but with some improvements.
According to our sources, development on NiMH batteries started in 1967, building on the knowledge gained from Ni-Cd.
It wasn't a simple upgrade, though. There were challenges early on, especially finding metal alloys that were stable enough for long-term use.
So it wasn't a smooth transition.
Not exactly. There was a lot of research and development involved. Interestingly, there was also work being done on nickel-hydrogen batteries around the same time.
Nickel hydrogen, how are those different?
They were similar in some ways, but nickel-hydrogen batteries were mainly developed for specialized applications, like satellites.
Ah, so they had different performance requirements.
Right. They were designed for long-term use in extreme conditions, like the vacuum of space.
Back to NiMH, what was the key breakthrough that made them a viable alternative to Ni-Cd?
The big breakthrough came in the late 1980s, with the discovery of new high-energy hybrid alloys for the battery's negative electrode.
What was so special about these alloys?
Well, they incorporated rare earth metals, which significantly improved the battery's performance and longevity.
Interesting. So rare earth metals were the secret ingredient.
They were a key factor. There was a remarkable demonstration in 1987 by Willems and Buchau. They showed that a NiMH battery could retain 84% of its charge capacity after 4,000 cycles.
4,000 cycles. That's
It
incredible.
was a major step forward in terms of battery lifespan.
And this breakthrough paved the way for the first consumer-grade NiMH batteries to hit the market in 1989.
That's right, the NiMH era had officially begun.
So what were the main advantages of NiMH over Ni-Cd?
Well, the most significant was higher energy density. This means they could store more energy for the same size or weight.
So you could have a smaller battery with the same power, or a battery that lasted longer.
Exactly. NiMH batteries had about 40% higher specific energy compared to Ni-Cd. That was a big deal for consumers.
Definitely. Longer battery life is always a good thing.
Another big plus was the environmental aspect. NiMH batteries don't contain cadmium, which is a toxic heavy metal.
That's a huge win for the environment. As people became more aware of the hazards of cadmium, the demand for safer alternatives grew.
Absolutely. And NiMH batteries were a perfect solution. They also addressed another issue we talked about earlier, the memory effect.
Oh, right. Did they completely eliminate it?
Not entirely, but it was significantly reduced compared to Ni-Cd. You didn't have to worry as much about fully discharging them before recharging.
So, more power, better for the environment, and less of that annoying memory effect. Sounds like a winning combination.
It was. And just like their predecessors, NiMH batteries were produced in a variety of sizes, making them very versatile.
Where did we start to see NiMH batteries being used?
They quickly gained popularity in consumer electronics. Think digital cameras, portable gaming consoles, MP3 players. All those devices benefited from the longer battery life.
So they were powering the gadgets of the 90s and early 2000s.
They were. And even more significantly, they played a crucial role in the early development of electric and hybrid vehicles.
Really? That's interesting.
Yeah, the first commercially successful hybrid vehicles actually used NiMH battery technology.
I didn't realize that. So they were pioneers in the electric vehicle revolution as well.
They were a stepping stone to where we are today with EVs.
Beyond cars, they were used in medical devices, renewable energy storage, portable power banks. It seems like they were everywhere.
They were. They offered a good balance of performance, affordability, and environmental friendliness.
So to recap for our listeners, NiMH batteries offered higher energy density, no toxic cadmium, a reduced memory effect, and were still cost-effective.
They were a major advancement in battery technology, but as we know, the story doesn't end there.
Right, technology never stands still. What led to the decline of both Ni-Cd and NiMH?
Well, despite their strengths, they both had limitations that became more apparent as new technologies emerged.
Let's start with Ni-Cd. We talked about the memory effect and the environmental concerns with cadmium. Were there other factors?
Yes, one of the main limitations was their lower energy density compared to newer battery chemistries. As electronic devices became more power-hungry and smaller in size, the demand for batteries that could pack more energy into a smaller package grew.
So they were struggling to keep up with the demand for more power in a smaller space.
Exactly. And then there were the environmental regulations. The use of cadmium was increasingly restricted, especially in Europe.
Great. That was a major blow to the Ni-Cd battery industry.
It was. It became clear that the future of battery technology lay elsewhere.
Now what about NiMH? It addressed some of the shortcomings of Ni-Cd, but it wasn't without its own challenges, was it?
That's right. One of the main drawbacks of NiMH batteries was their relatively high self-discharge rate. They could lose a significant amount of their charge even when not in use.
So you might charge up your device, leave it for a while, and come back to find the battery drained.
Exactly. It wasn't ideal for devices that were used infrequently.
Were there other issues?
They also had more complex charging requirements compared to Ni-Cd. And while researchers worked to improve things like self-discharge and corrosion resistance, those improvements often came with trade-offs.
So it was a constant battle to find the right balance.
It was. And ultimately, a new contender emerged that outperformed both Ni-Cd and NiMH in key areas.
Enter lithium-ion batteries. Our sources point to their emergence in the early 1990s as a turning point in battery technology.
Lithium-ion batteries offered a significant leap forward in several key areas. They had a much higher energy density, meaning they could store more energy in the same space.
How much higher are we talking?
2 to 3 times higher than Ni-Cd and significantly higher than NiMH. This was a game changer for portable devices.
That explains why we saw such a dramatic improvement in battery life for things like cell phones and laptops.
Exactly. And there was another major advantage. No memory effect. You could charge a lithium-ion battery whenever you wanted without having to worry about reducing its capacity.
That must have been a relief for consumers.
It was. And they also had a much lower self-discharge rate, so they held their charge for much longer when not in use.
So longer battery life, no memory effect, and they were also lighter due to the use of lithium, which is a very light metal.
That's right. They were a winning combination.
It's no wonder they quickly became the dominant battery technology for portable electronics.
By the late 1990s and early 2000s, lithium-ion batteries were everywhere. They were in our cell phones, laptops, cameras, you name it.
And the automotive industry followed suit, right?
Yes. While NiMH batteries have been used in some early hybrid vehicles, the push for fully electric vehicles with longer ranges really accelerated the adoption of lithium-ion technology in the automotive sector.
It makes sense. For electric cars, you need batteries with the highest possible energy density and the lowest possible weight.
Exactly. And lithium-ion batteries delivered on both counts.
So lithium-ion batteries really disrupted the battery landscape. But does that mean nickel-based batteries are completely obsolete?
Not quite. They still have their place in certain niche applications.
Like where?
Well, Ni-Cd batteries, despite their limitations, are still valued in applications where their ruggedness and reliability are paramount.
Like emergency lighting and backup power systems?
Exactly. They can withstand deep discharge cycles and operate reliably for many years.
And what about NiMH? Where do they still hold their ground?
NiMH batteries remain popular in certain consumer electronics, like as rechargeable AA and AAA batteries. They're a cost-effective alternative to disposable batteries.
Makes sense. And they're still used in some hybrid vehicles, right?
That's right. While lithium-ion is the dominant technology in newer electric vehicles, NiMH batteries are still found in some older hybrid models.
So while they may not be the stars of the show anymore, nickel-based batteries still have their roles to play.
Absolutely. They were pioneers in rechargeable battery technology and helped pave the way for the innovations we see today.
It's been a fascinating journey through the history of battery technology, from the early days of Ni-Cd to the advancements of NiMH and the eventual rise of lithium-ion. And it all started with the insightful sources you, our listener, provided.
Indeed. It shows how each innovation builds upon the successes and addresses the shortcomings of its predecessors. The story of nickel-based batteries is a great example of how the pursuit of better energy storage drives technological progress.
It also highlights how understanding the limitations of past technologies can give us a better appreciation for where we are today.
And it can offer valuable insights into what the future might hold.
So, for our listeners who want to dig deeper, I encourage you to think about this. How did the specific challenges faced by nickel-based batteries, like the memory effect and the need for safer materials, directly influence the development and adoption of lithium-ion technology?
It's a great question to ponder. And as you explore those connections, think about how understanding those past hurdles can inform our expectations for future innovations in energy storage and beyond.
Because who knows what the next breakthrough battery technology will be. Thanks for joining us on this deep dive into the world of batteries.
It's been a pleasure exploring this with you. Until next time.